Okay, today we will be talking about classifying triangles and finding missing sides of triangles using some algebra. So we're taking what we learned last class and we're applying it to this new method. So the first question here, we have a triangle and we have some information. If point M is the midpoint of JL, classify JKM by its sides. So first of all, we have three options, right? We're going to have equilateral, which is when they're all the same. We're going to have scalene when they are all different. And we are going to have isosceles for when two are the same. So those are our three options. So we are going to be trying to find, I want to just label everything that I possibly know. So the first thing I'm seeing here is that this is 0.75, and so this one must also be 0.75. And we know that just from the way that our picture is marked. The second piece of information comes from right here. Point M, that's not a highlighter. Point M is the midpoint of JL. So that's going to bring me here. If M is my midpoint, then these are each half. So this would be 0.75, and this side is going to be 0.75. And so now that I have every single piece labeled, all of my sides, I want to look at triangle JKM. JKM is this triangle right here that I'm doing in orange. Notice I have 0.75, 0.75, and 0.75 as all three of my sides. So even though it may not look it, this one is absolutely equilateral because all of them are labeled as 0.75. So hopefully you can see here how we're using midpoint and we're using that segment addition postulate and some of the things we learned in chapter 1 to apply them here in chapter 4. The next scenario is a little different. You'll deal with problems like this one a little bit more often. This is giving us a triangle and it's telling us that ABC is isosceles. And we can see right here that these are the two sides that are congruent because they have those two isosceles markings on them. So if we want to be able to find all of those side lengths, well, being an isosceles means we have two congruent sides, which are two equal measures. So I can set 4x plus 1 equal to 5x minus 1/2, and I can solve. So I want to get all my x's together and all of my other values together, so I'm going to add 1/2 to my constants. So that is 3/2, and I'm going to subtract 4x equals x. So x equals 3/2 here. I want to plug that into both of my sides. So think 5 times 3/2 minus 1/2 is going to give me 15/2 minus 1/2 is 14/2, which is 7. The same thing should happen over here. 3/2 times 4 is going to be 6. 6 plus 1 is also 7. And we don't want to forget about this guy. We're doing 9 times 3/2 minus 1. That is going to give me, what do we have here? We have 27/2 minus 2/2 is going to be 25/2, which is 12.5 for my third side. So we have 7, and 12.5 on our isosceles triangle. The last problem I want to do is very similar, except now we're using an equilateral triangle. Equilateral is going to mean that all three of these are the same. So in the previous example, we had to set 4x plus 1 and 5x minus 1/2 equal to each other. In this example, we can actually just choose 2 out of the 3. So let's go with these two. 2y plus 5 equals 3y minus 3. And it would not have mattered which ones we picked. I'm going to add 3 to both sides. We get 8 and subtract 2y from both sides. And I just get y. So here my y equals 8. And I love this problem because we can actually check and make sure that we did our algebra right, because all three of these should come out to the same problem. 2 times 8 is 16, plus 5 is 21. 3 times 8 is 24, minus 3 is 21. 5 times 8 is 40, minus 19 is 21. So this one checks out. I also want to bring your attention down here. There was a second part of this problem that asks us to find the perimeter. Okay, in order to find the perimeter, we add all the sides of our triangle. So 21 plus 21 plus 21, we would have gotten 63 units for our perimeter. So just a friendly reminder, sometimes they'll ask you to solve for y, and you can stop once you've gotten 8. Sometimes they'll ask you to plug back in and find all your side lengths here like we did for 21. And other times still, they're going to ask you to find the perimeter. So just be conscious of what a problem and task always is asking of you. So these are just 3 examples. You'll do some practice, and remember, you're always applying the things that we've learned in algebra with the things that we've learned earlier in the year, compounding into these new things. So you always want to make sure you're reflecting back on our prior knowledge here. All right, I hope this helped.